Welcome back. This is my next map tutorial where we are gonna build a cloud map. First, I will show you how to get global cloud coverage data, and then we will turn it into an animated visualization. We will start from global geotagged raster grids, TIFF files, and we will end up having one animated GIF file. Just so that we have a nice contained image, we will now focus on Southeast Asia. Let's get to it. To collect global cloud data, I went for the EarthEnv platform, where they provide global 1 kilometer grid-based cloud cover, so cloud cover rasters, all across the globe, going back to 15 years with 2 measurements a day. They also provide aggregated rasters, which are going to be pretty large raster files. You can download them simply by clicking on the download button. So these raster files contain the number of cloudy observations for each pixel twice a day at most, going back to 15 years. So here I downloaded the data for every single month starting in January and going up all the way to December. So make sure that you also have all these TIFF files downloaded, and once you have that, you can move on to the Python part. As usual, I will add the website here as well, and you will also find the code and all the details in my Substack newsletter. So after adding the link, I will also do a few standard inputs which we will need to be able to work with raster data. And I will also define a function which will be our helper function, which will take the path of a raster grid and a bounding box. Additionally, I will define the following bounding box, which, as you will see on the maps, is a nice fit for Southeast Asia. The reason I picked this part of the world because when I was exploring the global maps, it had a really nice and really interestingly changing cloud pattern over the course of a year. And by year, I mean not an actual calendar year, but an average year, because we have the data files from Modis. Oh yeah, let's list them. So we have the data files, which correspond to each month from January to December, but they don't cover one month, but they cover all the months of the past 15 years. So they are a typical January or an average February or an average June or December of the past 15 years. But just for the sake of simplicity, I will refer to them as January, February, and December, and so on and so forth. So once we have all these files listed, we will use these file path to feed the crop and read function, where we simply read the raster grid with raster.io, and we make sure that the data is cropped to the bounding box, and then we will return the data itself as an array and its extent. So from the documentation, we will know that the total number of observations over the course of 15 years during 365 days and 2 times per day is exactly 909,500. And for a quick test, let's build one map. Let's see how it looks like when we visualize it. So we will pick the first file, which should be corresponding to the average January. We get the cropped data, we normalize it, and then we clip it to make sure that it falls within the 0-100%. So now we are not studying and not visualizing absolute cloudness levels, but relative cloudness levels, which is fine because now we don't want to measure the level of cloudiness with pinpoint accuracy, but we would like to see a global picture of how the biggest trends of cloudness change over the course of a year in Southeast Asia. So let's do these few steps and then start to create our first visualization. We will have the canvas. Just to be able to name the plot well, let's extract the ID from the file name, the ID of the month, and then turn it into the name of the month. Then this is where the magic happens, where we visualize the raster data using matplotlib's imshow. And then we will also add the subtitle. So the title, the month, font size, and all the things we can customize, we do here. And then we switch off the access because now that won't be very interesting for us. And show the map. Yeah, maybe we can decrease the size a little bit so it fits this screen better. Yeah, so this is a cloud map of Southeast Asia. So here the font size should also be decreased. And let's see what happens if we change the color map to something that also has, for example, red and blue in it. Probably the color map cool, for example. Yep. So the more purple, the more cloudy. Let's see how, for example, the plasma color map looks like. Yeah, maybe not the best either. Let's see the one called winter. And by the way, I am checking these color maps here on my other screen, so you can also just explore different color maps. Yeah, let's use the winter one. It seems alright. Or maybe try this one. I've never seen this before. Wistia. Yeah, no. Let's go back to the winter color map. Okay, so now we have the winter color map. Now let's define a function. It's gonna be simple. I will call it plot a frame. It will take the name of a raster file, and then I will do everything that we have done here before. So it's just copying and pasting all these lines of codes. Just define the file directory, do the cropping, do the scaling, do the plotting, give a title to the plot. And then finally, here we are not closing the image, but saving the frame, saving the image as a single frame. And let's see how it works. Okay, now I'm going to show the results just to make sure that this works. We also go to the winter, go for the winter color map. Oh yeah, and PLT show. Yep, now it looks more sensible. Still pretty large, but don't worry, now we will keep it at this higher resolution and decrease the resolution just right after we join these frames. Now it's time to iterate over all the files and simply create all the frames. Then we will import image.io and the Python image library to be able to work with the images much closely. And what's going to happen here is that first we load all the frames as image objects. Then we will define. So what we have to do now is that we are going to have 12 images, and we want to create an animation, a GIF, where first we see one image, January, and then we will see February, the next one, but we want to make sure that the transition is smooth. This will require us to somehow create a few intermediate images which will bend together one frame to the next one. So this is happening here. First we create the frames. So once we created them, we should have the frames stored in this list as images. They can also be shown as a code cell output. Now we will need a longer batch of code right here, where we are going to iterate over each frame and each quote-unquote next frame, turn them into arrays, and then using this line of command, we will bend them together using different levels of opacity. Here we have 3 different alpha parameters, which will mean that we will have 3 different levels of like bending together. That's gonna be fine. We will have the list of images. Let's see. Image interrupt 0 should be a proper image of January. And then image 2 should be something between January and February, as you can see here. Now let's export it in a way that all these images are going to be joined into a GIF. with a duration set for each frame. And finally, we will be able to show this here using this simple command, where we will move from frame to frame. Let's change the size a little bit so we can see the whole map on the screen. And if we don't like this, we can slow it down with the duration parameter. And see how the cloud level changes over Southeast Asia. Since we have 12 original frames, and for each transition we added 3 more frames, we should have 45 frames. Let's confirm. Yep, we have 45 frames, and if the duration of a frame is 0.1 second, then the whole animation is about 4.5 seconds. And that's why it finishes so quick. So there's one thing we can do here. We can set the loop flag to be 0, and we can even increase this to 1.25. And in theory, now we should have a bit longer GIF, which will start to go back to the origin and run round and round forever. So that's how we can create a global cloud map showing how the air changes and how the humidity in the air. So just we connect to this 30-day map challenge topic. So that was it for this video. Thank you very much for following, and see you next time.